Hello students, welcome back. Lesson 10 is a continuation of Lesson 9. We're going to continue upon quadratic functions, but we're going to focus upon applications, especially two types of applications. Lesson 10a, Quadratic Inequalities, which is rather pure math oriented, and Lesson 10b, Quadratic Models, and that's far more empirical. Here, Lesson 10a, Quadratic Inequalities. As I said, this is rather pure math oriented, but this is still important because we are talking about a synthesis of two different systems, graphical and algebraical. Let's see how we synthesize these two. Let's begin with a motivating example. And here we go. X squared plus 4x minus 5 is less than 0. All right. Whenever I write this kind of problem in an intermediate algebra, I see this kind of answer a lot. Sometimes even more than half the students. Less than 0, okay. And then factor the left-hand side. Again, all looks good. And then, just like solving an equation, blue inequality, red inequality, and thus blue solution and red solution. Looking good? Not really. You just earned an automatic 0 credit. Automatic 0 credit. Now, if this had been an equation problem, everything would have been okay. This would have been a perfect 10. X squared plus 4x minus 5 is equal to 0. After factorization, we have blue times red is equal to 0. So blue is equal to 0 or red is equal to 0. So we have blue equality and red equality, and from there we get blue solution and red solution. All good, perfect 10. It works for equations because in the second line we have this 0 property. Blue times red is 0, so one of them has to be equal to 0. There's no way we are going to get 0 by multiplying two non-zero numbers. That's why it worked, the 0 product property. Now, if you have inequality on the other hand, it doesn't work that way anymore. Blue times red is less than 0. Does that mean any one of them is less than 0? No way. In order to have something times something less than 0, in other words, blue times red is negative, we have to have two opposite signs. Positive times negative is negative. Also, negative times positive is negative. If you multiply negative times negative, then the result is positive. This second line doesn't work anymore. So this entire thing is false and automatic 0 credit. So how do we make it right? One way to do it is to use logic like this. Same idea, blue times red is less than 0. And then we use this logic. Blue is negative and red is positive, or blue is positive and red is negative. So from these four inequalities, we get these four. X is less than negative 5 and x is greater than 1. X is greater than negative 5 and x is less than 1. And then also there are some additional difficulties versus and versus or. And even worse, what is this? X is less than negative 5 and also greater than positive 1. That's not possible. So the former is impossible, that just drops out, and we just have the latter, greater than negative 5 but less than 1, so we get this double inequality. X is greater than negative 5 and less than 1, and consequently yielding this interval expression, open interval negative 5 to 1. Now, did you follow all this? If you did, great, but, oh come on, that's a bit too much. If you're going to go over to more higher or rational or something more complicated, transcendental and so on, then you need these kind of ideas. So in STEM algebra, we do this. But that's a bit of an overkilling for our purpose. So we're going to rely upon a graphical method. Did I say before that we're going to focus upon the synthesis of two different systems, graphical and algebraical. Let's use that. Let's go to the same problem. X squared plus 4x minus 5 is less than 0. And let's do it in graphical method. So factor it as before. And then graph it. What do you get? We get y equals to x squared plus 4x minus 5, which can be factored as x minus 5 times x minus 1. So this basically is a intercept form of the quadratic function. This one, by the way, is general form, and that's the intercept form. And that's less than 0. Less than 0. Y-coordinate is less than 0. What does that mean? The graph must be below the x-axis. Do you see this color coding? I emphasize this part in red. This product is less than 0. You see? Less than 0. That means this expression, y-coordinate, has to be less than 0. So graph has to be below the x-axis. We're talking about this portion. See? The algebraic expression less than 0 and geometric expression below the x-axis, you have to synthesize those. And then one more synthesis. Which x interval corresponds to this portion of the graph? From -5 to +1. So we get this double inequality, or equivalently we get this interval expression, -5 to 1. Open interval because equality x equal to -5 and also x equals to 1, they do not qualify. If this had been semi-inequality, for example, let's see, semi-inequality. If the original problem had been semi-inequality, then all these would have been semi-inequality, and consequently, we would have had brackets here. So that's an adjustment of the problem. Let's go back to the original. Originally, I had strict inequality, and thus everything has to be strict. And thus everything has to be open. What if I had greater than 0 here? Then y-coordinate is greater than 0. So this product has to be positive, greater than 0. Y-coordinate is greater than 0. That'll have to correspond to above the x-axis, right? Can you synthesize the graphical and algebraic information here? Greater than 0. This time I'm using blue color coding for an obvious reason. Greater than 0, y-coordinate is above the x-axis. So in this graph, above the x-axis, you have to look at blue regions. So we have two curved pieces here, also there. So the solution would have been, let's see, x is less than -5 or greater than 1. Let's see. Another way to write the same thing is like this. Everything is greater than -infinity. So less than 85, but consider that greater than -infinity is hidden. Same goes here. Everything is less than +infinity. So it simply says greater than 1, but consider that less than infinity is hidden, so that you get this kind of interval expression a little bit more easily. -infinity to -5, or so you have to have union 1 to infinity like this. So if I change the original problem into greater than equal, then you have to look at this part and that part. So two curved pieces, so you need two intervals. First interval here and second interval here. First interval here and second interval there. Again, the same idea applies if I change this into semi-inequality. If these had been greater than or equal to, then what will happen there? X equal to -5, x equal to +1 would have been okay now, right? So these changes accordingly. And these do not, nothing is equal to infinity or negative infinity. So infinity, negative infinity side, always strict, always parenthesis. Only these change the bracket, kind of like this. So we end up doing all four types of inequalities. Originally we had strictly less, but with a semi-equality version. And then we changed the direction, and then greater version we did it, and then we changed into semi-inequality version. We ended up doing all four types. Not enough time to go through another example problem. So here, let me just go back to where they used to be. Okay, I got back to the original expression, and that's it for the first problem, and we'll do other problems in separate videos. Stay tuned.